Let's see how we can put the BST node and the in-order traversal to work together. And let's now consider one JUnit test case that's also available on your source code. And besides tracing on the paper, you're also encouraged to try to launch the debugger and use a breakpoint to really walk through the steps one by one if necessary to help you understand further. But let's now take a look. And the focus for this one here is about setting the references for the parents and the left and right subtrees. That's something we want to focus on. But let's take a look. Overall, we're going to create 7 BST nodes together. Some of them are meant to be internal, so you can see that's why we actually put a key and also the values over here. All of them are meaningful. On the other hand, for the 4 external nodes at the bottom, or the leaf nodes, we simply don't put any meaningful value to be stored, neither the key nor the value. And then we'll have this fragment of code over here to set up the references for the parents and for the both child nodes. And then we'll try to call the in-order traversal utility method that we just defined earlier, and then we try to see what the return value is. So that'll be the overall picture for the test case. Let's now take a look. To start with, I would like to show to you how you can create internal nodes over here. So this part over here is about the internal nodes. Okay, let me just make a note over here. So these are the internal nodes that's meant to be. And this part over here is meant to be the external nodes, this part over here. However, their runtime structure will be identical because they are instantiating the same class, but just that it's only a matter of whether the fields for the attribute will be null or default values. And for this part here, they are meant to be external nodes. You can also observe this from the naming convention. You can see EXT standing for external. And let's now try to draw the nodes to trace the code. So the template is already here. Let me just copy that. And then let's start with the first one. N28. And it's going to store the key 28 and the data value string Alan. Let's see how we can do that. So we're going to create this object here. Let me just make it a little bit smaller. Okay, that should be good enough. Let me also copy that for later. Okay, so this one here, let's see each field one by one. The parents initially just going to be null. And what about the key? The key value is going to be 28. And the value is going to be Alan, the data value. So that one there is going to point to Alan. And what about the left and right? The left and right, to begin with, is simply just going to be null. So the left and right, in the beginning, will just be null. That's the first node. What about the second one? The second one is going to be done in a very similar way. So for that one, I'm going to be faster. Okay, the second one over here, the third one over here. So far, they haven't become really parent and child nodes just yet, but we'll do that later. So for the second one, you can see the third one is going to be 21 and also 35. So 21 and also 35. And for the data value, Mark and also Tom. So this one over here is going to be Mark. And this value over here is going to be Tom. And for the left and right, they will all be null. Left and right, and left and right, they will all be null. What about the external nodes? For the external, you know what, before that, let me also try to put the references as well, which will be important. So let's put N28 is pointing to this node over here, and also N21 is pointing to this node over here, and also N35. You can see when you try to be very precise about the details at the runtime structure, things wouldn't work out as pretty as you were hope for. But anyway, I'm gonna do the simplest tracing as well at the end, just to show you the tree diagram. But I think that this might be worth doing anyway. Well, what about this part over here? For this part here, maybe I wouldn't just reproduce the same structure, because we know that these 4 nodes are meant to be external nodes. So why don't we just draw in the simplest way, which would be something like this. Let's say we got 1, 2, 3, 4. So 1 here, and also 2 here, and also 3 here, and also 4 over here. And as a look ahead, the reason that I want to also annotate about their references over here is because I want to show to you about aliasing, which is also important. All right, get there in just a moment. And we got external N1, N2, N3, N4. Let's now annotate them as well. So this one over here would be, let's say, external nodes 1. And this one will be external node number 2. External node number 3. And finally, external nodes number 4. So far we have done these lines of code. And then this part over here, we're going to set the parents and also left and right child. Let's be careful, okay? Let's now talk about the parent. Why don't we just try to do the parent first? And let me highlight every line that's to do with the parents. This one here, 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 and this one over here. Let's go line by line. It happened that in this case, the sequence of executing the set method doesn't really matter because we are trying to set different attributes. But of course, if you want to just follow exactly the same sequence as suggested by the code, if you want to do these first, that's okay too. But let me just go for the parent first. So N21 does set parents N28. So N21 does set parents N28 is like this. You can see N21 is pointing to, you can see N21 is pointing to this node over here. The set parents is going to be N28. Right? That's this line over here. The next one, let me just say check, it's done. What about this one here? N35 set parents N28. N35 is pointing to this node over here, and the set parents N28. So it would be this one over here. And then external one, still set parents 21. So we got these two. Let's do these two together. Both nodes will set the parents to be N21. So external 1 and 2. So external 1 is going to have its parents pointing to this node over here. And external number 2 is also going to point to over here. So the convention would be the orange over here is a parent reference. And also external 3 and 4 set their parent to be 35. Okay, so parents over here, and also parent reference over here as well. And we're done with half of them over here. Let's talk about setting the left and right. And setting the left and right, let's now try to take a look. N28 does set left, N21. N28 does set left, N21, which will be this node over here. So what's going to happen is, it's going to point to this node over here. So maybe let me just delete this just to be a little bit better. And also, N28 does set right, N35. N28 does set right, N25, which will be this node over here. 35, sorry, N35. Right, you can see so far we have done symmetric references setting. For this node over here, its left child is this node. Symmetrically, the node's parents is the same node over here. And I will write some assertion down, which was not included in the test, just to show to you about aliasing. I'll do that in a moment. Let's finish them. And also, N21 does set left, N21 does set right. Okay, let's now take a look. And you should also watch out for what's being set over here. So N21 is actually this node over here. The left should be this external node over here. And the right should be set to this external node. And let's continue. N35 and also N35, right? To set to the child node to be, the left should be N3, the right should be N4. So what's going to happen is this will be the left and this will be the right. You can see we've got so many references over here to be set up, right? And of course, implicitly, the external node 1 does left should be null. And also external node 1 dot right should be null as well. And similarly for all the other 3 external nodes. Let's now go over for the rest of the code over here, and I'll show you some assertion for aliasing in just a moment. And we can now invoke the in-order traversal starting from N28, which is over here. And let's recall what we did earlier, so I don't need to really trace the method line by line. In order for the in-order traversal to work, we start with the root over here. We have to recursively in-order traverse the left subtree, and then followed by the root, and then followed by the in-order traversal of the right subtree over here, right? So that means we're going to follow the order of N21, followed by N28, and also N35. So that'll be the order, which is not surprising. And when we encounter any child nodes that's actually external, they will be ignored, if you remember. If the current root that we're considering is actually not internal, so that'll be the else part, which will be simply just null, and they will not be included. All right? That's something we also said before. All right, so this part over here is rather straightforward. You just have to make sure you understand about the order. So you can see we just want to get a key from the in order list over here. That one's going to store different nodes. You can think about that simply just going to be an array list. And then we got index 0, index 1, index 2. Index 0, index 1, and index 2. Index 0 is actually going to point to this node over here. And index 1 is going to point to this node over here. Index 2 is going to point to this node over here. So we follow 1, 2, and 3. That's exactly the in order we're expecting. And if you try to get their key over here, it's going to be 21, 28, and 35. That's exactly the sorting property that we spoke about earlier. That's also very worth noting. So 21, 28, and also 35. Let me just highlight it and annotate it. This is the sorting property on the keys. Sorting properties on the keys. Okay, two more things I would like to do. Number one, I want to show you a slightly more simplified version of the tree nodes. At the moment, it's very complete about the runtime structure. You see the parent reference, you see the key, you see the value, you see the left, you see the right. But it could be a little bit messy when you actually try to trace faithfully, especially if you got the tree maybe with more than 3 nodes. In that case, it will be too complicated for you to draw. So let me show you another way. And for now, let me just get rid of this. But you have to make sure for every node, especially internal node, you have to include all the necessary information, namely the key and the value. Let me show to you. So alternatively, you can draw it in this way. Alternatively, which way to use really is up to you and also up to what you really need in order to solve the problem at hand. And the first one over here is going to be internal nodes. Okay, so this will be the first one. Okay, I think that's good. Let me just copy that. And the first one, we're going to say key value pair. So it's going to be 28 and Allen. So I can put 28 over here and Allen. Of course, it's much easier. The only catch is when the data object over here is rather than just a string value, in which case you can just put it here. But if the data value is actually some object structure, maybe person or maybe account, or maybe just another tree, in that case, of course, you cannot just draw like this. You have to make some pointer reference to other objects. But this depends on the example. And we got another one over here. Okay. Another one over here, and also another one. Oops. Another one over here. Okay, that's good. So the second node will be 21, and also Mark. And the third one will be 35, and also Tom. And of course, what we can do is we can simply just draw the links between them, just like that. And a line like this really suggests about the symmetry of the references. We got a child reference for the left child. Also, we got a corresponding parent reference as well. So drawing this should be enough. But of course, if you really want to see exactly what happened, this might be the way to go. It's kind of up to you. I'll leave the choice to you. Right, that's the first thing I like to do, which is to show you the alternative way to draw the tree. The second one, which is also very important, is about the aliasing. Let me write it down over here. If you take a look at the reference over here, for example, let's start with this node over here. We know that n28 dot get left is going to give you this particular node over here, right? And what about n28 dot get left dot get parents? Is going to be referring back to this node over here. It's actually important to see this. So what I want to show to you is simply just some example. If I try to evaluate the following Boolean expression, number one, I'll show you maybe a couple. n28 equals, I can say n28 dot get left, and then dot get parents. This one apparently is going to be true. This one's obvious, right? As I just explained. Let me see if I can give you another example over here. Another example would be, what about, of course, if I ask you a different question in the assessment, of course, the best way to do is to draw the diagram, and it doesn't matter how I put the question, you just have to follow the direction of the arrow. Let me just give you one more. Let's say n28, how about this? n28 dot get left equals, and then I would say n28 dot get left dot get right, and then dot get parents. These are all valid constructs to really make in OOP. And this one here is also going to evaluate the true. That's just a second example. But let's see why the second one will also evaluate the true. Let's see. n28 is referring to this node over here. Dot get left is going to refer to this node over here, right? So we're talking about n21. And let's try another way. If we say n28 dot get left, again, it's this node over here. Dot get right, which is going to get to this node over here, referred to by this external node. And then get parents is going to go back. It's going to follow the parent reference and go back. And that's really referring to the same node. So that's why they're the same. Of course, when the tree structure gets more complicated, you will really have to have this kind of a diagram drawn in order to trace the references. So that's why I said, depending on what the problem at hand to really solve really needs, you should really decide either to use this way of tracing, which is very simple, or you may have to use this one over here to trace the aliasing. Both are useful. That's why I'm showing you both. Alrighty, so we are now done with discussing the implementation details of a binary search tree, especially how we can implement utility method and how we can construct trees using the tree nodes. And the next part, we're going to see the various operations for binary search tree.